Hey! Welcome back to Innovative Creator. Toyota has brought about an automotive evolution that is destabilizing the entire electric vehicle industry. And let's just say that EVs might never be the same with this engine. According to Toyota's CEO, Toyota has made an engine that will destroy the entire EV industry. We are talking about an engine that is completely different from the current EV engines. But does this mean we are about to see one of the greatest shifts in the automotive landscape? Let's find out. Before we can take a look at what Toyota's CEO revealed, let's first go back and understand where they have come from. When it comes to the fast-paced world of automobiles, Toyota is making one of the boldest claims, and it has the entire electric vehicle industry buzzing with pure anticipation. To understand what we are talking about, imagine a groundbreaking engine that leaves even the most dedicated car enthusiasts on YouTube completely speechless and electrified. This new engine is a true game changer. Not so long ago, Toyota announced the development of a new hydrogen combustion engine. However, this is not like any other hydrogen combustion engine. Unlike other car manufacturers that have gone all electric, Toyota has decided to take a completely new path. They have come up with an entirely new technology that we have never seen before. Just as the name says, the hydrogen combustion engine makes use of hydrogen as its main fuel source. Unlike other engines that emit carbon dioxide as a byproduct, this one emits water from its exhaust pipe. This is Toyota's approach to minimizing the carbon footprint around the world. But let's get deeper into the engine. As we have already seen, Toyota has taken a completely different route to reducing its carbon footprint around the world. Instead of following the trend of electric vehicles, they have decided to go with a hydrogen combustion engine. Hydrogen is one of the most abundant elements in the universe. In addition to that, it has the highest specific energy density of any non-nuclear power source. When it is used as a fuel, it is purely exhaust-free and non-toxic, given that even its byproducts are just water. Given its composition, it can be created using many sources, stored indefinitely, and even shipped easily. You may not know this, but millions of tons of hydrogen are produced and used without incident every year. It is already in use as a power source in some buildings, electric cars, forklifts, ships, and even trains. Yes, not everything you see runs on gasoline. The Toyota hydrogen combustion engine makes use of a fuel cell, which converts hydrogen into electricity. Take, for example, the Toyota Corolla Cross H2 concept car. It comes with a 1.6-liter turbocharged, 3-cylinder engine that runs purely on hydrogen. But how did Toyota make this a reality? Well, let's just say that this was the point Toyota started revolutionizing the entire EV industry. With these new engines, the entire EV industry was about to change, and it would never be the same again. Keep watching to find out how they do it. Toyota uses thick, armored fuel tanks to store the highly flammable hydrogen fuel. This idea was picked up from their FCEV, the Mirai. However, it doesn't have to be too large. The Corolla Cross H2 concept car only uses just 5 kilograms of hydrogen, and this is enough to give it a range of about 300 miles. And what about its byproduct? It only produces 50 liters of water. And last we checked, water is not that bad for the environment, unlike carbon dioxide. To make this concept even better, Toyota has partnered up with Yamaha Motor to create a V8 engine that is powered by nothing but hydrogen. This engine is actually quite powerful, producing about 455 horsepower and 398 pound-feet of torque. Just to make it stand out, they also added an 8-to-1 top-mounted exhaust manifold, which creates a pretty unique high-frequency sound. When you compare the Toyota hydrogen combustion engine with other electric vehicles, the hydrogen engine has a lot of advantages. The main advantage is that it has a larger range, and refueling is as fast as a drag race. By achieving this, it reduces the need for limited supply materials such as lithium and nickel, all of which are critical to the manufacturing of EV batteries. Even though this car uses a battery to store some power, it is not as large as an EV battery. As of the last quarter of 2023, the Corolla Cross H2 concept car was undergoing some real-world evaluation and winter road condition testing in northern Japan. And so far, there have been very positive reviews about it. Generally, Toyota's new hydrogen combustion engine is a true game-changer when it comes to the automotive industry. It has got to be one of the most environmentally friendly engines, producing only water as a byproduct. In addition to that, it also has a longer range, faster refueling times, and reduces the need for limited supply materials. We are yet to find out how the real-world testing goes, but it won't be long before we start seeing these cars on the road. If the hydrogen-powered engine were to become successful, the Japanese government plans to have about 200,000 fuel cell-powered vehicles on the road by 2025, which is in 1 year. To add to this, they plan to add all this up to 800,000 by 2030. To support this, it goes without saying that they have to build more refueling stations across the country. We have already seen that the hydrogen combustion engine is unlike any other. But what about the pros and cons of this engine? Well, let's start with the pros. The first one, which is also the most obvious one, is that it is a very eco-friendly engine. Given that it uses hydrogen as its source of fuel, it doesn't have harmful byproducts, just as we have said. Furthermore, hydrogen is a clean fuel on its own compared to traditional gasoline engines. The second advantage is that this engine has a very effective cooling system. The innovative water cooling system addresses one of the major challenges of an engine, which is the high temperatures. This system, which comes with hydrogen combustion engines, potentially enhances engine performance and longevity. This means that things like overheating problems would become very rare if the engine were to be used in the real world. And, as we all know, that is something that would really save a lot of drivers. The third most common advantage is that this engine uses completely familiar technology. Since the engine mainly operates on a system similar to traditional engines, it is easier to integrate this engine into other automotive design and manufacturing processes. This is a great advantage for Toyota because they can just modify some of their other cars to integrate this engine. This engine has clearly made some strong points when it comes to its advantages. However, nothing is without its disadvantages. And the very first disadvantage is the production and infrastructure of hydrogen. We have already seen that the engine is more than eco-friendly. However, what many people don't know is that this is completely dependent on how the hydrogen is produced. At the moment, even though there is widespread production of hydrogen, it is not always sustainable. Therefore, if these cars are meant to be produced in large quantities, then the automaker has to figure out how to deal with this issue first. As much as hydrogen is there, even in lower quantities, there is still a problem with the hydrogen fueling infrastructure. Given that hydrogen cars are not as common, there are very few hydrogen fueling stations compared to gasoline and electric charging stations. The other problem that comes with hydrogen combustion engines is their complexity and cost. As much as it uses a similar architecture to other engines, it has a dual water injection system. When you combine this with the need for precise control by the ECU, the entire system becomes a bit complex. An increase in complexity automatically adds to the manufacturing costs for the automaker. On the other hand, it also becomes costly for the owner to maintain this car, mainly because the parts are not as common. Let's say that Toyota was to achieve large-scale production of this engine. They would still have to deal with the issue of market readiness. As of now, the production-ready version of this design is still in development and testing. Even if it were to be passed as ready for the market, the automaker would definitely need more time before the car would be commercially available. By making this hydrogen combustion engine, Toyota has demonstrated its commitment to exploring multiple solutions for sustainable transportation. And in addition to the electric and hybrid engines they have come up with, the automaker has come up with a different solution. This hydrogen combustion engine represents the automaker's interest in diversifying its sustainable vehicle options. Now, we have been talking about the combustion engine from time to time, saying how good it is and how it will destroy the entire EV industry. But how different is it from the traditional internal combustion engine? What are the technical aspects of this engine that make it stand out even more? To answer these questions, we will focus on one of Toyota's standout achievements in this field, which is the 1.6-litre, 3-cylinder turbo engine. For those of you wondering why we are looking at this specific one, it is because it is one of Toyota's most successful hydrogen engines. It is currently being used in the Corolla cross-hydrogen prototype, and it is performing wonders. This engine perfectly blends traditional design with pioneering technology, and it is good at it. However, it is completely different from a conventional internal combustion engine. You see, the 1.6-litre, 3-cylinder turbo engine is just marvelous when it comes to the world of engineering. Toyota based this engine on the same platform as the engine found in the GR Yaris. And as we all know, the GR Yaris is known for its performance and agility. However, for the engine to support hydrogen as a fuel, Toyota had to make several modifications. After these modifications, a lot of people had a lot of questions about it. However, one question that everyone was asking was, how did Toyota manage to maintain the engine's performance while switching to a completely different fuel source? The secret lies in the hydrogen combustion process. Compared to gasoline, hydrogen requires completely different handling and combustion techniques. And with that in mind, the engine uses a high-pressure hydrogen direct injection system. This is a significant departure from traditional fuel injection systems. With this system, the engine can control the delivery of hydrogen into the combustion chamber. This greatly optimizes performance and efficiency. But even with this, how is the engine's overall performance impacted? You would be surprised at how this hydrogen engine performs. The 1.6-litre engine can produce enough power and torque to compete with its gasoline counterparts. This is mostly thanks to the turbocharger, which plays a massive role in ensuring that the engine delivers the necessary boost to make it high performance. However, there have been concerns about whether turbocharging is actually the way to handle the unique properties of hydrogen. The main reason for this concern is that, compared to gasoline, hydrogen has a relatively lower density. Because of this, the engine would require a larger volume of hydrogen to achieve the same energy output as gasoline would. Toyota's engineers have not overlooked this, taking the challenge head-on. They have ensured that the turbocharger and other parts of the engine are properly optimized to handle the unique properties of hydrogen fuel. One of the things that makes this engine even better is its efficiency. It turns out that the efficiency of hydrogen combustion engines is way higher compared to that of traditional engines. This effect is felt more during high-load situations. As a result, it greatly affects the fuel economy and has an environmental impact. With the increase in efficiency, it means that the engine has a better fuel economy. And most importantly, it means that there is a significant reduction in emissions. After all, the only byproduct of the entire combustion process is water vapor. This technically means that it has near zero emissions. And just as we saw earlier, this makes it one of the most environmentally friendly options out there. Achieving near-zero emissions from the hydrogen engine is important for Toyota, mainly because it is in line with the carbon neutrality campaign that they are on. As Toyota moves towards a future of carbon neutrality, the automaker has employed more than one strategy to achieve this. And instead of a one-dimensional approach, the automaker has opted for a rather diverse application of hydrogen and electric technologies. Given their technology, the automaker can gladly accomplish this with a one-dimensional approach. But why go for a multifaceted approach in its quest for carbon neutrality? To understand this, let's start with Toyota's commitment to hydrogen technology. But you might be wondering, why go for hydrogen? The answer lies in its potential as a clean energy source. When hydrogen is used in fuel cells or internal combustion engines, it only produces water vapor. This means that it is the most environmentally friendly alternative to fossil fuels. However, Toyota's investment in hydrogen technology is not just for passenger vehicles. Toyota has actually used this technology in commercial vehicles and even public transportation solutions. But is hydrogen technology alone enough to achieve carbon neutrality? Let's just say that Toyota has looked into this because, by recognizing the limitation of using a single technology, Toyota has also embraced electric vehicle technology. One of the main components of Toyota's strategy to achieve this is the development of battery electric vehicles. However, they have used a rather different approach to this than other automotive manufacturers, especially those focusing entirely on EVs. Toyota's diversified strategy keeps in mind that there are some challenges to the widespread adoption of EVs. The most rampant of these challenges include the limited range, long charging times, and the environmental impact of battery production and disposal. To deal with this, Toyota has offered a range of powertrain options, the most common being hydrogen fuel cell vehicles, plug-in hybrid electric vehicles, and BEVs. With these powertrains, Toyota is aiming to cater to a broader spectrum of customer needs and driving conditions. This whole diversified approach all leads to the broader goal of carbon neutrality. However, Toyota has managed this in various ways. And one of the things they have done to understand this is to realize that different regions and markets use different energy sources, infrastructure, and environmental policies. However, producing a one-size-fits-all approach may not be as effective as expected in reducing global carbon emissions. For example, consider regions where they use reusable energy. For such a place, BEVs would be the most suitable option. On the other hand, when you go to areas where hydrogen production is powered by renewable sources, FCEVs and HYSES could be a better option. Nonetheless, when you consider Toyota's commitment to carbon neutrality, it goes way beyond vehicle emissions. The company is actively taking part in initiatives meant to reduce the carbon footprint of its manufacturing processes. And to achieve this, they are now promoting recycling and the efficient use of resources and investing in renewable energy projects. However, there is still more that could be done to achieve the ambitious goal of carbon neutrality. To understand the impact of Toyota's strategy, you must keep your eyes open and look at the bigger picture. To achieve a society that is almost fully carbon neutral, it would require lots of changes to happen. This is not only true of vehicle technology but also of the production of this energy. With Toyota's multi-technology approach, which has been coupled with its initiatives in other sustainability areas, it is clear that there is a comprehensive effort to address these challenges. Apart from achieving carbon neutrality, this move from Toyota also has some environmental benefits. In fact, they may be more than you could even imagine. But to understand that, let's move back for a bit and take a look at these benefits. You see, as the automotive world is slowly shifting towards the development of sustainable energy, Toyota's hydrogen-powered internal combustion engines bring about a fascinating proposition. But how do hydrogen engines compare when you compare these engines with hybrid electric vehicles and plug-in hybrid electric vehicles? To answer this question, we will first look into another question. What makes hydrogen engines stand out when it comes to their environmental impact? The main factor to look at here is the emission profile. It goes without saying that traditional gasoline engines emit quite a large volume of carbon dioxide. Technically, this is the greenhouse gas that is playing a very huge role in global warming. On the other hand, Toyota's hydrogen engines produce no carbon dioxide whatsoever during their entire operation. And for those of you who think that achieving zero carbon emissions is impossible, it is very much possible. The secret to this is all in the combustion process of hydrogen engines. When the hydrogen fuel in these engines is burned, it reacts with oxygen from the air to produce energy. Not to get into much chemistry about this, but when hydrogen and oxygen burn, they combine to form H2O, which, as we all know, is water vapor. This is the only byproduct of the entire process. Just as we have seen, the removal of carbon dioxide emissions from the tailpipe is a very huge step towards reducing the automotive industry's environmental carbon footprint. But what about HEVs and PHEVs? For HEVs, which stands for hybrid electric vehicles, they combine a gasoline engine with an electric motor. On the other hand, PHEVs, which stands for plug-in hybrid electric vehicles, can be plugged in to charge their batteries. At the end of the day, both of these engines will offer improved fuel efficiency and reduced emissions compared to traditional gasoline vehicles. However, this does not take away from the fact that the engines still rely on gasoline. Therefore, they still produce carbon dioxide emissions during operation. And even though it is in lower amounts, it is still there. On the contrary, hydrogen engines offer the potential to achieve true zero-emission driving. However, this is only possible if the hydrogen fuel is sourced sustainably. Another environmental aspect to consider is the life cycle emissions of these vehicles. When HEVs and PHEVs are being made, they are combined with batteries that require rare earth elements. And to make these batteries, it requires a lot of energy-intensive manufacturing processes. It is these processes that emit more carbon into the environment, which is the issue that should be addressed here. However, even with all this in mind, hydrogen engines have managed to avoid all these challenges. The production of hydrogen fuel, especially when it is derived from renewable sources such as wind or solar power, can be less environmentally taxing than battery production. And when you consider this, it offers a more sustainable overall life cycle. In addition to all that, we have already seen that the hydrogen combustion engine is practically more efficient than the traditional combustion engine. This is mostly relevant for heavy-duty applications, where the efficiency of hydrogen engines can match that of hydrogen fuel cells. Fuel cells have a high efficiency peak when they are at a low load, but this tends to drop when they have a higher load. But on the contrary, hydrogen combustion engines have a peak at high loads, which makes them suitable for use in places where high performance is required. And as the world is constantly fighting the challenges of climate change and resource depletion, technologies like Toyota's hydrogen engines offer a ray of hope. They have definitely promised cleaner, greener transportation, all without compromising performance or practicality. And speaking of performance, we have mentioned that hydrogen engines will somehow have similar performance to gasoline engines. But how do they actually achieve that? The secret to achieving this is the nature of hydrogen as a fuel. When you compare hydrogen as a fuel to gasoline, hydrogen burns relatively faster. This relatively faster combustion means that this engine would have higher responsiveness, which is a crucial factor when it comes to performance driving. But does this have an effect on the overall driving experience? When it comes to a conventional internal combustion engine, drivers are used to a certain level of performance. They are also used to immediate throttle response and a certain growl when the engine is running, which gives them a certain sense of power at their fingertips. You know what we are talking about. Like when you hear that Dodge Charger running. The intriguing aspect of HICEVs is that they are also able to mimic these characteristics. Even while using a clean fuel source, drivers of Toyota's hydrogen-powered cars can still experience the same sensation that comes from driving a conventional car. This includes everything from the sound of the engine, which, if you ask most automobile enthusiasts, is an integral part of the driving experience, to the power that comes with it. But do they also perform the same as conventional engines? Toyota has put this engine to the test in the demanding world of motorsports. The perfect test was when they added a hydrogen-powered vehicle to the racing series. This not only demonstrated the robustness of this technology but also its potential to be used in high-performance applications. In this high-stress, high-demand environments, HICEVs have shown that they can compete with traditional cars toe-to-toe. They can also offer comparable speed, agility, and endurance, which are crucial during these moments. Believe it or not, hydrogen engines are also capable of delivering horsepower and torque similar to gasoline engines. These are pretty promising results, all things considered. By making some changes to the existing engine designs to accommodate the combustion of hydrogen, Toyota has managed to achieve power outputs that are on par with conventional engines. There are even times when these power outputs from hydrogen combustion engines are higher than those from traditional engines. Such an achievement is a technical milestone and a testament to the potential that hydrogen can be used as a viable alternative fuel for high-performance vehicles. However, some people have asked whether these hydrogen-powered vehicles can give the same driving pleasure as their petrol counterparts. Even though this is the most subjective aspect of HICEVs, early indications have suggested that it is very possible for them to give the same driving pleasure. There have been drivers who have volunteered to take Toyota's hydrogen-powered vehicles for a spin. And according to their reports, these cars offer a driving experience that is both familiar and exhilarating. This combines traditional internal combustion engine dynamics with the novelty of using a clean, sustainable fuel source. By making cars that retain the performance characteristics of conventional ICE vehicles, Toyota is greatly bridging the gap between the present and the future of automotive technology. And whether it will be used for the daily commute or the adrenaline rush of the racetrack, HICEVs will surely deliver the performance, sensation, and enjoyment that drivers have grown to love about traditional cars. They will achieve all this while still ushering in a new era of environmentally conscious motoring. So far, we have seen that Toyota has been working on its hydrogen combustion engine. And from everything we have seen so far, this is an engine that is going to revolutionize the EV industry. However, they have an even crazier engine coming. And if it were to make it to the real world, it would completely destroy the EV industry, or what's left of it after the hydrogen-powered engine. Imagine having an engine that runs on water. Yes, Toyota has been diving into the world of engine technology that runs entirely on water. This marks a significant leap in the pursuit of sustainable solutions. But before we get into the details of this initiative, let's take a minute to look at the theory behind the water-powered engine. The idea of an engine that runs on water sounds like something you would see in science fiction. However, Toyota has taken up the challenge to make this a reality. The main principle behind this technology is to use water as a source of fuel. But where exactly will the energy come from? I mean, water is the most inert thing ever, seemingly having no energy. The answer to this is in the chemical composition of water. Water, which is scientifically known as H2O, is made up of two hydrogen atoms that have been bonded to one oxygen atom. And so, to unlock the energy potential of water, you just have to figure out how to separate these hydrogen atoms from the oxygen atom. Luckily, there is a process for doing this, which is known as electrolysis. Electrolysis involves passing an electric current through water to break it down into its constituent elements, which are hydrogen and oxygen. Alone, hydrogen is a high-energy fuel. And when it is combusted, it can produce significant amounts of energy, enough to run an engine if combusted in larger quantities. When it comes to Toyota's water-powered engine, the hydrogen extracted from water would be used as fuel in a combustion process similar to that of traditional gasoline engines. However, unlike gasoline, the combustion of hydrogen still produces water as a byproduct. And as we saw earlier, this means zero carbon emissions. When Toyota achieves this water-powered car, it will be a true game-changer in the industry. This would be a highly appealing technology in the context of environmental sustainability. Another intriguing aspect of Toyota's water-powered engine initiative is filing patents related to this technology. According to the patent filings, Toyota's commitment to developing and protecting this innovative technology suggests a serious investment in making water-powered engines a reality. But how will Toyota even integrate this technology into practical automotive applications? The integration of water-powered engines into vehicles presents numerous challenges. The major challenge here would be integrating an efficient electrolysis system into the engine. Furthermore, they would have to think about safe hydrogen storage solutions and engine designs that can handle the unique properties of hydrogen combustion with all this in place. However, given Toyota's record when it comes to innovation and technological breakthroughs, these challenges are something that they can conquer. Toyota has definitely damaged the entire EV industry with their hydrogen combustion engines. But when they unleash the water-powered engine, it will never be the same again. Thanks for watching, and I'll see you in the next one.